Today, we are from Group 10 will present proof techniques, which is the last chapter of discrete mathematics. Next, I will introduce our group members. First, Muhammad Hishamuddin, DW220010. Next, Muhammad Aiman, AW220154. Next, Muhammad Shafiq, AW220058. Ahmad Naim, AW220057. Next, Daniel Hakim, AW220214. Next, Hafizuddin, CW22006. Last, Shahmi Mirza, CW220057. First and foremost, I will start this presentation with introduction. Proof can be defined as a way to show the truth of some word or sentences. However, in this topic, we are going to introduce you with two types of common proof techniques, which is deduction or direct proof and proof by contradiction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hishamuddin bin Jerami. I will continue to explain about direct proof. Direct proof is you can directly prove that if you add an odd integer with an even integer, you will get an odd integer. The solution will get let A equal to odd number and B equal to even number. A plus B equal to 2m in bracket plus B for even integer, which is A equal to 2m. We can get, after that we got 2m plus 2n plus 1 for odd integer. B equal to 2n plus 1. After that 2 we simplify, 2m plus n in bracket plus 1. 2 is taken as a common factor for equation, and finally we get 2p plus 1, which is odd number, is proven. Next, I will go to proof by contradiction, which is proof that if n power of 2 is even, then n is even. For the solution, if n2 is even, then n is odd, making negation from initial statement. N equal to 2m plus 1, which is for odd integer, n equal to m plus 1. After that, n power of 2 equal to in bracket 2m plus 1 power of 2 square root both sides. Next we got n power of 2 equal to 4m power of 2 plus 4m plus 1, which is a expression, and then n power of 2 equal to 2 in bracket 2m power of 2 plus 2m plus 1, which is simplifying the term. And finally we get n power of 2 equal to 2k plus 1, which is 2m2 plus 2m equal to k, which is the odd number. The final answer shows that n power of 2 is an odd number, which is a contradiction with the negation made in the first line. Thus, the original statement is true.
First question, direct proof. The question is direct proof that every sum of two square odd integer produce even integers. The solution is, firstly, we need to write formal statement, which is the solution is firstly we need to write a formal statement. 2n plus 1 power of 2 plus 2n plus 1 power of 2 equals to 2k. Second step, we try few samples. 1 square plus 3 square equals to 10. 3 square plus 5 square equals to 34. 5 square plus 7 square equals to 74. Next, 7 square plus 9 square equals to 130. 9 square plus 11 square equals to 202. 11 square plus 13 square equals to 290. The last step is find the pattern. 2m plus 1 square plus 2n plus 1 square. 4m square plus 4m plus 1 plus 4n square plus 4n plus 1. So we got 4m square plus 4n square plus 4m plus 4n plus 2. And the problem solving is even number.
So the conclusion is every sum of two square or integer produce even integers. The statement is directly proven.
Problem solving calculation. Proof by contradiction. Question. Proof by contradiction where the negative or an irrational number is also irrational number. Solution. Number 1. Write a contradict statement. There is at least one irrational number n such that n is rational number. Step 2. Try out and find out the truth of the statement. Let negative n equal to a over b, n over n equal to negative a over b, a equal to integer, b equal to integer, negative a equal to integer, negative b equal to integer, a over b equal to rational number, b equal to 0. Step 3. Make conclusion. If a and b are integers, thus it shows that n is a rational number. The original statement where the negative or an irrational number is also a rational number is true and contradicts with the initial assumption statement.
For results and discussions of the analysis. Direct proof. Objective. Proof that the sum of two squared odd integers always results in an even integer. For notation, 2n plus 1 and 2n plus 1 represents odd integers, while 2k represents an even integer. For any integers m and n, if 2n plus 1 and 2n plus 1 are odd integers, then 2n plus 1 power of 2 plus 2n plus 1 power of 2 is an even integer. For example, m equal 1 while n equal 2. Calculation. 21 plus 1 power of 2 plus 22 plus 1 power of 2 is equal even number, that is 34. Expand squared expressions. 2m plus 1 power of 2 equal to 4m power of 2 plus 4m plus 1. 2n plus 1 power of 2 equal 4n power of 2 plus 4n plus 1. Substitute expanded expression. 2n plus 1 power of 2 plus 2n plus 1 power of 2 equal 2 multiply 2m power of 2 plus 2n power of 2 plus 2m plus 2n plus 1. Assuming two square odd integers results in 2k, while k is an integer. Since 2k represents an even integer, the original statement is proven. For results and discussions of the analysis, we have proof by contradiction. There is at least one irrational number n such that negative n is a rational number. Assume n is an irrational number. Consider negative n and express it as a fraction a over b, squaring both sides. N power of 2 equal a over b power of 2. Rearranging, n power of 2 equal a power of 2 over b power of 2. This implies n power of 2 is rational since it can be expressed as the quotient of two integers. The negation statement contradicts our assumption. Therefore, the negative of an irrational number is proven to be irrational.